So hello, I'm that cube guy that you probably know because you cursed me with this name, and I'm here to talk a bit about Bullet and its underused potential. So when we hear Bullet simulation, we probably think about destruction, debris, death, decay, and yeah, we use Bullet to break things and then cover it with 7 layers of smoke. Uh, but in reality, Bullet is a multi-purpose tool, and we kind of use it like this. Well, obviously, Bullet was used for all kind of things, and you probably saw a bunch of papers being used in for learning for things. But in perspective of VFX artists, especially in Houdini, we just break things. But we can do much more, and I will provide an overview and a little demonstration. And we will start this overview with that video that probably everyone saw. Yeah, that's right. Come on, presentation. Show me that.
Needs a bullet also.
Thanks. Yes, that one. So that one was about all the small guys fighting each other, but this is like a small example of non-destructive bullet usage, and it's very simple. There's boxes with cylinders and like 8 constraints, maybe a bit more now that I look at it. I don't quite remember. So very simple. The wheels don't even change, don't even turn. Simple, stupid, works fine. Now let's get to the next one. The next one is that thing about the car in a cube or something. So if you think about it, that video was all about Bullet. Sure, there was some pyro simulation, but whenever this GIF plays, you will see that it's actually stock pyro sim with just feedback enabled. There is no magic here. The valve to the right hides the fuel source field that gets sucked in by the piston that operates as a collider, and the smoke gets pushed out from the left valve and actually gets sourced into another purely decorative smoke simulation. But here, pyro just pushes on the bullet object, which is the piston. And yes, the dope feedbacks in Houdini is another topic that is interesting and way underused. But that would be a topic for another discussion, maybe much more interesting than this one. So here, after the pyro pushes, it's all just bullet. It's all one bullet mechanism with constraints. The piston pushes the thingy rotates that thingy. The axis that gears with those little cylinders push the valves up and down, and we have ourselves a moving car after all. But strip that from pyro, and what you have is a bullet mechanism driven purely by bullet engine, and it's not even a big one. You can probably count all the objects here by fingers, maybe a bit of toes. And without the pyro, again, it runs real time. It's very light. So we definitely know that you can go much further than this. And one thing that mesmerized me in this one is the gears. It's a very simple concept. The cogs or gears, how you call them properly. Very simple concept, just 2 things pushing on each other, but somehow they look fancy. They look more complicated somehow than, say, a rope or chain made of all the twist constraints, and yet much simpler to do. So, reasonable question: how many of the gears can be put together and Bullet still works? Well, Bullet definitely works better than this presentation. Like LibreOffice. I understand you're free, but come on. You cannot support videos or GIFs. Look,
It shows it.
the cooler goes off just to show this. Anyway, what we see that we can basically put a lot of them on without even stressing, without cranking up constraints or substeps on the simulation. So how far should we go now? A real gearbox maybe? Why aim so low if we can aim to, well, a full mechanical processor? And at first that sounded undoable, but when eventually I got over the fear of trying to attempt this project, I bravely thought, okay, let's do what? Let's do full x86 architecture, right? Should be easy, 32-bit, you know, GPU there. I know I already had plans how to do the display with, flipping triangles for different colors. Yeah, then obviously this went into garbage straight from the thought process. Well, can we do say 16-bit CPU? Sure, they were still mainstream just not so long ago. But then you think just to implement say the whole full memory array, you need what 65 times 16 parts for the memory, and each part just for with the simplest estimation give you at least 5 parts, gears, no, 5 bullet parts say, per part. Also a bit intense. So 8-bit. 8-bit is doable, right? Well, 8-bit is really, I think, doable, but not for this laptop that barely can run this presentation. So, yeah, after designing some circuits, I thought that's a bit too much. So we go to set pathetic 4 bits, and as you see, I'm only thinking in powers of 2. So 4 bits it is, 16 words of memory, 4 bit each, and that's not enough to say even hold program and data at the same time. So this one actually had 2 sets of memory for 16 words each, one for commands, one for volatile memory. And what do you know? It ran beautifully. Well, after a bunch of tweaks here and there, it ran fine, and it could do arbitrary programs. And you can see here it's a program.
The other laptop's working. Do you want that?
Nah, it's fine. It's fine. Yeah, we stick with this one. Thank you.
We've got it back.
You know what? I forgot to press record on OBS. Someone will kill me. Let me just do that right now. No one will know. Let's pretend that it's the beginning. Well, anyway.
Okay, you'll just record when you get home.
Yes. So this here you can see it's running a program to search an array of 12 elements for repeating for how much certain item appears in that array, and it's running blazing fast. That took only 5 days to complete. To be fair, the bullet worked reasonably fast, not real time, and note that this ran not even on ridiculous constraint settings or iterations. I saw people cranking up those bad boys even higher just for a simple box shattering. So, but to switch all the logical elements in one chain, it took about like 450, 500 frames. So this program with the loop took many thousands of frames to run. So, yeah, 5 days, not that bad after all. The point is that the concept was proven, and you can do, at this point, you can say any kind of complicated mechanisms with Bullet. Bullet, you can say, even is Turing complete. So, meaning you can implement any kind of conventional algorithm with Bullet. Not that this is only or best proof of that.
Sorry, are they concave or convex, the cogwheels?
Oh, of course, they're all convex. Concave is no. It's
when they're convex, You mean that they are decomposed? Each like tooth is a different.
Yes, they originally created in a way to be only convex shapes, because yeah, concave is a weird beast. I think bullet library itself works fine with concaves, but for some reason Houdini just cannot work with concave objects without decomposing them into convex ones. So theoretically, this could be scaled as long as you have more resources into any other machine. Let's assume that. And what can we conclude out of all this experience? That little set of rules that I developed from here is first, don't make tight connections. So obviously, if you just shove a gear in between two gears that it cannot even solve its position, that's not good from the beginning. But even if you push them too tightly, as you see on the lower line, they will start oscillating and colliding with the gear teeth will start colliding with previous and next one, and you will have this cranky motion in the end, even with just a tiny amount of gears. Okay, so now next one is very obvious and applies to everything. Every kind of bullet simulation is keep masses within reasonable ranges. You don't want things like weighing 1 milligram colliding with 100 tons, and that result in bad experiences. So, and the third one would be minimize and always keep in mind the maximum length of your contact chain. Where contact chain is something very self-explanatory. It's a chain of contacts. So how many things touch each other from some beginning, which is in case of gears is probably a motor, all the way to the end that doesn't push anything. Another example would be, say, a pile of grains. If you have grains on the bottom would be the start of the chain, grains on the top end of the chain, and all those small friction and load on those gears or weight of those grains will accumulate going down this chain to so that at the bottom you will have under-resolved grains or under-resolved chains, gears in this case. And the solution for this kind of problem actually comes from the example of grains. You can modulate masses of gears at the beginning of the chain, so they are higher there, and then solving those constraints would be easier. Though I actually didn't have to do this for anything, for any mechanisms, and this probably would be required for much bigger ones. So yeah, just to be fair, as probably you had the idea that it's all that simple and easy, but actually no, I think that CPU project was one of the most complicated things I've did. And yeah, unfortunately there was so many things left behind the scenes that maybe deserve another discussion, all the concepts and the solutions thrown away. But for now, probably you are thinking, why? And for example, if you would want to calculate the amount of times some element appears in an array of 12, you can just use, again, fingers and toes, and it will take you probably just half an hour instead of 5 days. But this is fun. It's fun doing. Well, honestly, it's fun to see these things come alive, and it's fun, watching. But if you want some other excuses, I can bullshit something like you can say you can design real life mechanisms. Well, as long as you don't care how gears are attached and other parts to the real container or something, and as long as you don't care about any stress on those attachments, yeah, sure. Other thing I can think of is that, well, it's just like with micro expressions on the face. If you make a real mechanism, it works and just gives it that little touch of reality. But yeah, that's a bit of bullshit excuses. Anyway, let's just go and make something with all that we know now. And what can we make that is well, simple and contains a lot of gears? Pendulum clock. Let's do that. So if you think about it, the clock is actually, well, any clock is actually some driving gear that just rotates with a constant velocity and a bunch of other gears to change the speed of this rotation to whatever you need: hours, minutes, seconds, milliseconds. And the gear that the motor, the main motor that rotates at the constant velocity, always is, well, some motor and limiter. And limiter can be, say, quartz crystal that oscillates at the same frequency, or some single atom that oscillates at known frequencies as atom clockwork, or an actual pendulum that oscillates. Uh, and one good thing about pendulums that we know from school is that within small amplitudes, its frequency doesn't even depend on mass. It's just, well, length. In case of more complicated pendulum, more real pendulum, I'd say uh, inertia tensor as well. But anyway, within small masses, small amplitudes, and as long as we are pretty close to this idealistic massless rod with massive bob, I think or we will get something very close to frequency independent of, well, anything. And now, how do we use that to limit the rotation? There are many ways. We will choose something like this. Here, that yellow wheel is called escape wheel, and that gray thingy that is attached to the pendulum is pallet, I think. And as you see, it doesn't allow escape wheel to turn faster than, well, the pendulum oscillates. And because of those angles of those hands of the pallet, the wheel gives back the energy to the pendulum, and it being much more massive than, say, the torque being applied to the escape wheel, will not change the frequency of its oscillations, but instead that energy will go into keeping the amplitude within, so pendulum doesn't stop. So yeah, I think we have enough now. So let us go right in. Oh, thankfully it works. And we should be able to just go ahead and do it. Since we don't have like infinite amount of time and there is a lot of repetitive work that you're probably not interested in, I've prepared a couple of assets. Let's see. For example, we will start with the heart of the clock, the escape wheel and the, well, pendulum and all that. So what we will use for the motor gear, instead of actual motor, which is boring, we will use a weight that is winded up with a rope on, how do you call it? Well, axis, and it will push on it, pull on it. Yes, it will pull on it. So let's start with that rope. Well, making ropes in Bullet is actually pretty simple. Here I have a preset that, well, creates a rope with a weight, but there is nothing here that is complicated. It's just a line with some tubes copied onto it, with the last one of them replaced by a heavier tube. Come on. And constraints are created from the individual segments of the line. So there is just boring work that was hidden under this asset. And let's straight away test it. It creates constraints with the, well, it has some settings for the length of elements, for everything, and it creates constraints with the name rope because it's long. So we will start here with the simplest bullet solver, gravity. and object, and also we need constraint network. So we will use twist constraints for the rope. We just need to call it the proper way. Disable collisions between individual beads being constrained. Rest link we don't need. And now all we need to do is to pass the objects and constraints into it. Almost there. We didn't set up any parameters on the constraints, and well, actually at this point I really hope most of you are familiar with Houdini, because otherwise it would be a bit boring to watch. Well, yes, for the constraints we need to specify the axis, the goal and twist, goal and constraint axis, which we can do through attributes, but we will just set them constant here to look up, since our rope is always perfectly up. And it's a bit too big for our scale, just the display part. At this point, well, we have our constraints for the rope, and we can even test that it works by dropping it on the ground. Don't really need ground for the clock to work. Who knows? No, we don't, but this is just for the test. Yeah, that is as simple as that. Now we would want to create a thing to actually wind this rope onto. And for this, I've prepared a simple asset called axis, which is just a packed tube, nothing more fancy. We'll just merge them here. Where are you? Should be good enough. We can make it a bit thicker. Come on. This mouse. And well, to make constraining things easier, there is another asset prepared, which will attach all our axes to the world, and all actually, one second. So now, well, nothing is attached, because this this node will actually create another constraint named heart, and we need that to create hard constraints with that name. Whoop, whoop. Now, well, at least that one stays there as it should. But now there is one thing that we need to address before we continue, is that we forgot to look at our colliders, and they are not really good, because, well, first of all, we forgot to set up the convex hull per set of connecting primitives to have proper colliders on compound objects, and adjust the padding for our scale. Well, that's basically it. Now, let's create our first gear. The gear was also put into a little asset here, but again, it's not a big thing. It well, just creates the objects, and let's put it somewhere. Now this will be our escape gear, and as you see, this auto connector will just save us some time and connect it right to the axis, and connects things as they are positioned in space. So we need to make it look a bit more like that escape wheel from the GIF, and for that, well, we would want to set this upper size a bit smaller. And this offset. No, it should be. No, it looks kind of like the escape gear. Now I've also prepared the palette part. It's just a set of boxes, really. There is nothing interesting here. Here, just exposed control over the, well, dimensions of this, including the angles. That one we will put over the escape gear. And let's also make a pendulum, which is just a box with a cylinder. Oh, good, it's already there. We just need to connect them with an axis, which is I think it's like this here. Don't need it to be that big. Okay. Now, if I started this, it will just all fall apart. But well, that's because this thing doesn't connect anything other than gears to the axes, but it can also take an extra group. Well, why not call it extra? So I just mark with this group our objects, and well, at least they are there. Now, what we forgot is to connect the rope to the barrel. Well, let's disconnect this for now and see how we can do that. Well, we can just steal one of the constraints from here. So the rope constraints would be generated between each of those parts, and we can just steal the last one and rename one of those parts to the axis, just to do it much faster than creating it from ground up. And at this point, we will have exactly one primitive here with the 2 points, one of them being yeah, just one of them. One of them being this part. You can see, yeah. The second one is lower part, but the lower part we will just rename to the axis. So I will guess that it's the first point, well, second point technically, out of those two. And I will steal the name from the axis, knowing that there's just one primitive. And Y as well, we can raise it just a tiny bit up. And now the rope is attached. What you will notice is that right now this rope is undersolved. You see the constraints are stretching out, and well, since we're doing a pretty stable thing, we can just go here and increase the constraint iterations, and everything should just work better, not exploding. And that's what seems to be happening. Don't need the ground anymore. since the rope will be just hanging there. Now, before we connect the pallet back in, let's actually wind this thing. So to wind, we will just animate this axis. We will use the active and animated attributes for the axis to say for 100 frames we will wind it up, and then for 50 frames more we will let it sit there and relax, and then it can start going. So active will be equal to frame greater than 150, and animated equals not active. And also, since we're merging objects with and without active, we should set the default value for the active attribute to be 1, so that when they merge, other object gets default value of 1 instead of 0. And now, well, it's not doing anything, but it's because we need to actually animate it. And to animate it, I will just spin it for 100 frames. And I just need to spin it in the right direction as well. And I think I have a mistake somewhere here, like this. Now it's spinning up, but it's spinning up and does nothing because we forgot to copy the active and animated attributes back to the bullet object, which can be done very simply with enabling this attribute override. Now it will wind up and unwind. So you can see that there are little instabilities here as the rope is winded up. We can actually, well, they are not fatal for us, but we can actually go there and increase the amount of substeps to 20, which will make it already much more stable. And now let's go and return our palette. So at the moment of winding, there will be a lot of penetration and well, nasty things happening to Bullet, but it's a tough boy. He can handle this, thankfully, without exploding. And there we have our clock going without anything extra. So all we have left to do is just, well, to make a bunch of gears to, well, change the speeds of all this. And, well, this is pretty boring. So I have a little preset for this. Come on. Now I will steal the parts from here. And start connecting them just one by one, so demonstrate as if we were creating it by hand. Well, first of all, we should lift that guy up to the axis so it's actually connected. I know it's shifted here and a bit here. So after that, we're just creating gears and not thinking about things. Now you can already see that that's already looking cool. Now we add another gear there and another slow down gear, and then actually we will use these two as our hour and minute arrows, but we really want the arrows to be actually in the same place, so we want to have another axis at the same place where the upper one is. So we will add two gears with the same ratio. Oh, actually, let's turn that so we see it from here. And now we have our hour and minute gears at the same place. All left to do is to put arrows there. Now there is one little trick with the arrows, and everything is the same, except for that they are penetrating through each other, and well, one of them will be attached to this axis, one of them will be attached to this axis, as you see by their main positions, but now they're going through each other and through the other axes, so we will set them collision group of arrows. And you also see that I set them density to be 10, so they're very, very light and don't really affect any other parts of the mechanism, so that you don't think that the whole thing works just because the heavy arrows are pushing on things. So here is a little trick to make things not collide with arrows and arrows not collide with things. Unfortunately, Bullet is, at least Bullet in Houdini, is a bit stupid. If A is not allowed to collide with B, it thinks that B is still allowed to collide with A. So we need to make it understand that it's bad both ways. So for for collision group arrows, we will set collision ignore to be base and arrows, so it doesn't collide with neither of them. And for other objects, we will set collision group base and collision ignore arrows. And as long as I didn't mistype anything, this should actually work. And look at that, seems to be working. Well, yeah, here we have a working clock. We can set probably alarms here as well in the morning. Yeah, it will be an interesting project to convert the sounds of all the collisions into actual sound. But that's out of this scope of this presentation. So I think we're basically done here. So thank you for having me. And yeah, I will provide the links for this if anyone is interested in the mechanism. And anyway, I forgot. Yeah, the questions maybe not even not just about this, but any questions about stock prices for tomorrow? I can think of something. I guess no questions.
Just a slightly related comment to your little CPU you built. I saw somebody who implemented Minecraft in Minecraft.
Yeah, I saw that too recently. It's a bit. I don't want to say easier, but it's different because you have redstone that's already basically an imitation of the logical circuit. So you're basically constructing it from electronic parts. Here you have just rotating physical objects. But yeah, that was. Please.
Do you ever actually get to use any of this in your work?
That's a great question. No, and that's very, very sad, because at first when it was my first videos, it was like do it in a week and throw it in a video, and then I got more greedy and it took with the CPU more than 6 months of work that just went nowhere. No one needs this stuff. No one would probably even want to look at it themselves. Like you saw it in the video, that's enough for me. So yeah, that's a sad part, and it gets worse.
There was this Who Cabaret movie that had a character who had like the insides of the character were these clockwork things. So if they make like a second movie, maybe.
Oh yeah, just fire all animators, make the mechanism inside. They will. Disney does all this animatronics, so they are preparing for that automatic animation.
Yeah, look towards the future. I wanted to ask if you have, had success with the impacts data, because something that we haven't really been, successful in doing is that impacts data is giving you a bunch of things, but it doesn't give you the name of the packed object which collides.
It actually does. I mean, gives you name of the object that collides, and then it also gives you the primitive number of the collide. It doesn't give you the primitive number inside the detail that if you're talking about that, so you know that what collided, what bullet objects collided, but you don't know which exact primitives. But well, you can kind of estimate it knowing what is.
The idea of the primitive. Okay.
Yeah, yeah. There are some underwater stones with that, I would say, because the way it's calling the attributes by default is the same as what Vex binds, like primnum. Uh, so you need to rename it before using, otherwise, or bind it to something else. Yeah.
I don't know, but I know physics, I don't know bullet. Is each tooth of the gears a separate element in order to...
Yes. Let me enable the collider view, so you can see the blue. That not display geometry. So this is pure colliders. Well, and also constraints. Can make that a bit smaller. So yeah, this is how colliders look. Every tooth is a separate collider, as you see. Actually, the base itself is also made of smaller colliders, since it's all only convex objects.
And they have rigid bindings, right?
Well, the gear, this one, the gear itself is a set of colliders. It's not; they are not separate objects bounded by constraints. It's just an object can be a set of colliders, not just one collider.
That's how bullet works.
Yeah. So
And have you measured like performance of constraints? For example, if you have like a rope you can make with a series of, let's say, soft constraints versus the cone twist. So I guess a bunch of other constraints also can be like approximated with different ones. And have you like basically thought about which is faster? Like fewer more complex constraints, or like more simple constraints?
nothing struck me as being significantly faster. There are applications for which one is more stable than another. Like there was a, I mean, you can do, for example, metal rods bending and remembering the bend with cone twist is just very natural thing, as I think. But when you start to make it into a mesh, then cone twists kind of don't work that well anymore, and kind of starting fighting each other. That maybe can simpler simulate with something else. Nah. By the way, did you know that bullet is not physically correct? I mean, bullet itself is, but not in Houdini. That's a neat trick. Yeah.
There's some impulse left over.
Well, let me try to make a very quick demonstration of that. Oh. No. So, you think? Let's see. This is a box. Let's make it thin and small, like this.
Yeah, narrow things.
No. For right now, it's perfectly fine. Like you will see that. Why? What are you doing? That collider is a perfect box, not even convex shape in this case. So if I set it some initial state, like say rotation in x-axis, that's not rotation, sorry. Wait, man,
It hasn't reset
gravity, my constant enemy.
Do you like the gravity top, or the pop force gravity?
Now where is this works better with the. I wouldn't say it's work better actually. I'm not sure that there is a difference because in the end, bullet will understand it as, well, its own internal forces.
Yeah, in the pop force there's some more convenient controls, like you have a group, for example. You often get to not apply gravity to
Stupid
things
me.
which are not, started to move yet.
Okay, I will eventually do this. There is rotation. Great. Don't sleep on me. Okay, now if I do something like this, rotate it just a couple of degrees off the axis. You see what's gonna happen? Now, this is the physically correct behavior. It's called tennis racket theorem or Jenny-Bekoff effect, that things that rotate, well, things like this box rotate out of just a bit out of the scale of the axis will eventually flip. And this works fine until you do something like, I will transform just one vertices of this box by tiny amount. And I'm sorry for everyone keeping you here. And now, suddenly, this doesn't work. And not just it doesn't work like this, it does completely physically incorrect things. Things don't rotate like this. They don't conserve angular velocity, they conserve angular momentum. So it only understands this for perfect colliders like boxes, cylinders. So if I delete this transform that makes it not perfect box, you will see it starts rotating completely differently, as it should. And yeah, this was a very disappointing discovery for me. So yeah, that's a little sidestep.
Is there some use case that you prefer the old Houdini solver?
Yeah, that's a thing that I keep people hearing from time to time, like, oh, I will use the old one, it's more physically correct. No, no, it's not. The only thing is that
It's slow.
it's slow, it's the same, not physically correct, or maybe even worse. And the only thing that it's kind of funkier that you have these volume representations for collisions, and I did this dissolving physical object that actually like fall apart as they like dissolve small parts. So that's easier to do there, but you can do the same in Bullet if you really try. So no, I wouldn't prefer that. That's it, I guess. Yeah, thank you everyone for staying all this time.